Hi students, in this video, let's discuss the questions that were part of the permutation and combination quiz. Before you go ahead and see this video, make sure that you attempt all the questions that are part of the quiz. Alright, let's get started. We go to the first question. Let's read the question. In a bookshelf, there are 7 maths-based books and 5 science-based books. In how many ways can a person select 6 books such that at least one mathematics-based book and one science-based book is selected? Alright, what's the answer to this question? The correct answer is option B, that is 917. Let's discuss 2 methods on how to arrive at this answer. The easier method is find the ways in which you can select 6 books and from that subtract the violations. So over here you have 7 maths books and 5 science books. So that's a total of 12 books. Now from 12 books you can select 6 books in 12C6 ways. Alright, and what are the violations? It's mentioned that at least one maths and one science based book has to be selected. So the possibilities of violations is if all 6 books selected are maths based, so that can be done in 7C6 ways, right? Because you have 7 maths based books. And another possible violation is if all the 6 books selected are science based books, but this is not possible because you only have 5 science based books, so this is 0. Therefore the correct answer is 12C6. That's the ways in which you can select 6 books from 12 books minus 7C6, and that is 924 minus 7, which is equal to 917, which is option B. Now you can also think of it in this way. This is a bit longer method. Now what are the different possibilities? You could select 1 maths based books and 5 science based books, or 2 maths and 4 science based books. Similarly 3 3, 4 2 and 5 1. So these are all the possibilities, right? Now you can select 1 maths based book from 7 books in 7C1 ways, and you can select 5 science based books from 5 science based books in 5C5 ways. So this can be done in 7C1 into 5C5. Remember, because it's and, right, you're selecting 1 maths based book and you're selecting 5 science based books, so that's why you have to multiply over here. So over here you get 7C1 into 5C5, that's 7 into 1, which is 7. Similarly, you have to calculate it for each of these cases. So this is 105. Over here you get 7C3 into 5C3, that's 350. And 7C4 into 5C2, that's again 350 over here. And over here you have 7C5 into 5C1, you get 105. Now if you add each of these, you will get 917, which is the same answer that we got over here. And that's your answer, which is option B. Let's read the question. There are 10 identical textbooks on a shelf. David uses colored paper to wrap the books. 6 books are wrapped in red paper, 1 in blue paper, 1 in green paper, 1 in orange paper, and 1 in yellow paper. In how many decorative ways can he place the covered books in a straight line on a table? Alright, what's the answer to this question? The correct answer is option C, that is 5040. Now over here you have a total of 10 books, right? And each of these books, though when you started all the 10 were identical, but now 6 are of one type, like because they have red paper covering, and 1 has a blue covering, 1 has a green covering, and 1 has an orange paper covering, and 1 book has a yellow covering. So there are 10 items and 6 are of one type and the others are different, right? So the possible number of linear arrangements is 10 factorial divided by 6 factorial, and over here you simplified 10 factorial can be written as 10 into 9 into 8 into 7 into 6 factorial, right? Because 6 factorial is 6 into 5 etc. up to 1. Over here also you have 6 factorial, these two cancel out and you're left with 10 into 9 into 8 into 7, that is equal to 5040. It's a good thing to remember that 10 into 9 into 8 into 7 is equal to 5040 because we come across this in a lot of questions. Alright, let's read the next question. The total number of 4-digit passwords using digits from 0 to 9 that can be formed having at least one digit repeat is. Alright, What's the answer to this question? The correct answer is option D, that is 4960. Over here, these are the 4 places where we have to fill digits, right? Now, what is the criteria given? It's mentioned that at least one digit should repeat. Now, the easy way to solve this question is find the total passwords that can be formed and subtract the violations. So what are violations? Violations are cases where no digit repeats, right? Because over here it's mentioned that at least one digit has to repeat. Now over here 0 to 9 you have 10 digits, right? So each place can be filled in 10 ways. If you want to find the total number of passwords without any condition, so that's 10 into 10 into 10 into 10, so that's equal to 10,000. So that's what you have, the total passwords. And the violations are the number of ways in which you can fill 4 places in unique ways, right, from 10 digits. So that can be done in 10p4 ways. Remember, 10p4 is nothing but 10 into 9 into 8 into 7, and that is equal to 5040. So over here this is 10,000 minus 5040, which gives you 4960 as the answer, which is option D. Let's read the next question. Little Beena has to post 8 letters. Alright. Naughty Beena decides to post exactly 3 letters wrongly by putting them in the wrong envelope. In how many ways can she do this? Alright. So over here she has 8 letters which she has to post by putting them into envelopes, and she wants to post 3 letters wrongly, right? So what's the answer to this question? The correct answer is option A, that is 112. Now how do we get there? Now over here she has 8 letters, right? Now in how many ways can she select 3 letters from these 8 letters? She can do that in 8c3 ways, and we know 8c3 is nothing but 8 into 7 into 6 by 3 factorial, and 3 factorial is equal to 6. So this simplifies to 56. Now these 3 letters she has to post wrongly, right? So that's nothing but dearrangement of 3 letters. And remember, we have learned that dearrangement of n items is nothing but n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial, etc. up to 1 by n factorial. Now over here n is equal to 3. So dearrangement of 3 letters is 3 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial. So these two get cancelled out. 3 factorial by 2 factorial is equal to 3, and 3 factorial by 3 factorial is equal to 1. So over here dearrangement of 3 items is equal to 2. So therefore the correct answer to this question is given by the number of ways you can select 3 letters and post them wrongly. So that's 56 into 2, and that's equal to 112, and that's option A over here. Let's read the next question. How many 5-digit numbers can be formed using 1, 2, 3, 4, 5, 6, 7 such that the first and last digit is odd and digits do not repeat? Alright, what's the correct answer to this question? The correct answer is option B, that is 720. Over here these are the 5 digits, alright, and it's mentioned that the first and the last digit has to be odd. So this digit over here and this digit over here has to be odd. Now over here, what are the odd digits that are made available? You have 1, you have 3, you have 5, and you have 7. So these are the possibilities with which we can fill this place and this place. So this is 4. So this one can be filled in 4 ways. Now 1 would be consumed, so we are left with 3 more digits. So this place can be filled in 3 ways. Alright, now of the 7 digits which are given, which is 1 to 7 over here, we'll be consuming 2 digits in the first place and the last place. So we'll be left with 5 digits, right? Now 5 digits can be placed in 3 places. In how many ways? That can be done in 5p3 ways, which is nothing but 5 into 4 into 3, right? Remember, it's not allowed to repeat digits. That's why we take 5p3. And 5p3 is 5 into 4 into 3, which is equal to 60. Therefore, the number of ways in which you can fill this place and this place with odd digits and then use the digits to fill the remaining places such that the digits do not repeat is equal to 4 into 3 into 60. That gives you the answer as 720, which is option B. Let's read the next question. Anne has a gang of 4 friends. In how many ways can she invite 1 or more friends for a movie? Alright, what's the answer to this question? The correct answer is option B. Let's see how we get this. Now over here it said that she can invite one or more, right? So she can invite one friend, two friend, three friends, or four friends, because it's given that she has four friends. Now she can invite one friend in 4C1 ways, right? Any one of the four people can be selected. Similarly, 2 can be selected in 4C2 ways, 3 can be selected in 4C3 ways, and 4 can be selected in 4C4 ways. Now one way of solving this is you can individually find these values and add them up, or we have studied that NC0 plus NC1 plus NC2 etc. up to NCn is equal to 2 to the power n, right? And NC0 is equal to 1. So in this case, if you just want NC1 plus NC2 up to NCn, you just need to do 2 to the power n minus 1, and in this case n is equal to 4, so this will be 2 to the power 4 minus 1, which is 16 minus 1, and that gives you your answer as 15, which is option B. Let's read the next question. In how many ways can you distribute a book, a toy, chocolate, pen, pencil among 4 children? So there are 4 children and you have 5 different items, right? So the book can be given away in 4 ways, right? Similarly, the toy can be given in 4 ways, the chocolate can be given in 4 ways, the pen can be given in 4 ways, and the pencil can be given in 4 ways, right? What are these 4 ways? If the 4 children are A, B, C and D, what do I mean when I say that the book can be given in 4 ways? It means that either the book can be given to A or B or C or D. So that's 4 different ways, right? Therefore, distributing the book and toy and chocolate and pen and pencil can be done in 4 into 4 into 4 into 4 into 4. That's 4 to the power 5, which gives you the answer as option B. Let's read the next question. The flower amphora has circular buds in 7 different colors. Bob picks up one bud of each color and wants to make a garland with these. How many ways can he do this? Alright, what's the answer to this question? The correct answer is option A, that is 360, right? This is a case of circular permutation because a garland is a circular arrangement, right? Alright, and over here the objects are buds, right? So they look like spears, they are symmetrical top to bottom, or you can think that the arrangement is not distinguishable clockwise and anti-clockwise. That's why you have to divide with 2. So this is a case of circular permutation and objects are symmetrical top to bottom, hence you have to divide with 2, right? Therefore the answer is n minus 1 factorial by 2. Over here n is equal to 7 because it's 7 buds that are used. So the answer is 7 minus 1 factorial by 2, which is equal to 6 factorial by 2. That gives you the answer as 360, which is answer option A. Let's read the next question. In how many ways can you arrange 3 yellow balls, 3 blue balls and 3 green balls along a straight line? Alright, what's the answer to this question? The correct answer is option D, that is 210. Over here, the total number of items is 9, right? It's 3 plus 3 plus 3. And 3 are of one type, that means 3 are similar, 3 yellow balls. Similarly, 3 are similar because 3 blue balls are there, and another set of 3 items are similar, which are green. So the number of linear arrangements, right? Straight line means linear arrangement. Linear arrangements is 9 factorial by 3 factorial into 3 factorial into 3 factorial, and you can just simplify it like this and you will get your answer as 210, which is option D. Let's read the next question. It's given that NCR is equal to 15 and NPR is equal to 30. Now we need to find N and R. Now you can either use the options just and try which one works, or over here you can also use the property that NPR by NCR is equal to R factorial. Remember, we had discussed that NPR is equal to NCR into R factorial, right? Because NPR has selection and arrangement. NCR is only selection and R factorial is for the arrangement. R items in R places can be arranged in R factorial ways. Alright, now using this property, if you divide NPR by NCR, you'll get R factorial. Now over here NPR is 30 and NCR is 15. 30 by 15 gives you 2. Therefore, r factorial is 2, or that gives you r is equal to 2. Now, in the answer options, you just have option B and option C where r is equal to 2, right? Now, you can try these two and you will see that n is equal to 6 is the correct answer, right? What is 6c2? You will get 6 into 5 by 2, right? That's 15, which is correct over here. If you take 5c2, that's 5 into 4 by 2, which is 10. So this is not the correct answer. The correct answer is option B, that is 6, 2. Let's read the next question. How many whole numbers between 10,000 and 100,000 have the product of their digits equal to 8? Alright, what's the answer to this question? The correct answer is option E, that is there are 35 such numbers. Now, this is a 5-digit number, right? Numbers between 10,000 and 100,000 will have 5 digits, right? Because 100,000 is the smallest 6-digit number, right? And 10,000 is the smallest 5-digit number. So whatever is there in between these two will be 5-digit numbers. Alright, now we need to find numbers such that when you multiply the digits in these 5 places, you should get 8 as your answer. Now, over here, we know 8 is nothing but 2 into 2 into 2, or you can have 8 as 8 into 1, or you can get 8 as 4 into 2, right? Now, we just need to see in how many ways that can be done. Let's take 8 into 1 into 1 into 1 into 1. So this over here, in this case, you will have 1, 8, and the remaining digits will be filled by 1. So this can be done in 5 ways, right? That's just you have a total of 5 items and 4 are of one type. So that's 5 factorial divided by 4 factorial, which gives you 5 arrangements as possibilities. Now, when you take 4 into 2 case, one digit will be 4, one digit will be 2, and the remaining 3 digits have to be 1. Now over here, this can be arranged in 5 factorial by 3 factorial ways, because these 3 items are similar, right? So 5 factorial by 3 factorial gives you 20. Now 2 into 2 into 2 into 1 into 1. So this is the next possibility. In this case, you have 3 items which are similar, and then you have another 2 items which are similar. So this can be done in 5 factorial by 3 factorial. So this is 3 over here by 3 factorial into 2 factorial, right? So that gives you 10. Now when you add these 3 up, you'll get 35 as your answer, which is option E. Let's read the next question. Find x if 6x plus 6cx plus 6cx plus 1 is equal to 7cx. Alright, what's the correct answer to this question? The correct answer is option E, that is 3. Now to solve this, you can just use the answer options. That would be the best method, because otherwise you'll have to form equations, and it's much faster if you just try with the answer options. So for example, if you try answer option A, what is 6c2? 6c2 is 6 into 5 by 2, right? So that's 15. What about 6c3? 6c3 is 6 into 5 into 4 by 6, right? So that's 20. And what about 7c2? That's 7 into 6 by 2. That's equal to 21. Now 15 plus 20 is not equal to 21. Therefore, this is not the correct answer. Similarly, you can eliminate the wrong answers. So if you take 3, 6c3 is 6 into 5 into 4 by 6. That gives you 20 over here. 6c4 is the same as 6c2, right? 6c4 is equal to 6c2. Remember, 4 plus 2 is equal to 6. That's why 6c4 will be the same as 6c2. So what is 6c2? That's 6 into 5 by 2. That gives you 15, right? And what about 7c3? That's 7 into 6 into 5 by 6. That's equal to 35. Now 20 plus 15 is equal to 35, which is true. Therefore, answer option E is the correct answer. Let's read the next question. Find the maximum value of 10cx for any whole number x. Alright, what's the correct answer? The correct answer is option C. That's 5 over here, right? Now, you can note that the value will be the highest when x is equal to 10 by 2. That's 5 over here. You can also note that initially the value keeps increasing when you go from 0 all the way to 10, right? So 10c0 is 1, 10c1 is 10. So initially it increases, but then you will see that it will come back and then it will peak and then start decreasing. 10c10 is also equal to 1, and 10C9 is also equal to 10, right? So the middle value will be the highest value. So over here, when x is equal to 5, you'll get the highest value, and you can see that 10C5 is equal to 252. You don't need to find that out. You just need to know which one, where it will be the maximum. That is at x is equal to 10 by 2, which is equal to 5, and that gives you the correct answer option as option C. Let's read the next question. Find n if 6 into np3 is equal to np4. Alright, so what's the value of n? The correct answer is 9. That is option B. Now over here it's given 6 into np3 is equal to np4. So just substitute into equation. So you have np3 as n factorial by n minus 3 factorial, and np4 is n factorial by n minus 4 factorial, right? So this n factorial and this n factorial cancel out. Now cross multiply. So 6 into n minus 4 factorial is equal to n minus 3 factorial, right? Now n minus 3 factorial can be written as n minus 3 into n minus 4 factorial, right? Why is that so? For example, if n was 10, then n minus 4 would be 6 factorial and n minus 3 would be 7 factorial, right? So 7 factorial can be written as 7 into 6 factorial. So that's the same thing that we have done over here in terms of variables. Now this n minus 4 and this n minus 4 factorial cancel out. Therefore, we get that 6 is equal to n minus 3 or n is equal to 9. That is option B. Let's read the next question. Max is setting up his bookshelf. He has to select 20 books. He selects books from 4 genres: G1, G2, G3, G4. In how many ways can he do this? If he selects at least 1 from G1, at least 2 from G2, at least 3 from G3, and at least 3 from G4. Alright, what's the answer to this question? The correct answer is option A, that is 14C3. Right, we have done a lot of questions like this in the practice problems. Now over here, G1 plus G2 plus G3 plus G4 is equal to 20, right? Because at the end he's selecting 20 books, and every book is either from G1, G2 or G3 or G4, right? Now over here it's mentioned that at least 1 has to be from G1, 2 from G2, 3 from G3 and 3 from G4. So let's give them that. So 3 plus 3 plus 2 plus 1, that's 6, plus 2 is 8, plus 1 is 9. So 20 minus 9, that's 11. 11 is 20 minus 9. So you're left with 11 more books, and these can be distributed among G1, G2, G3 and G4 in a lot of possibilities, right? So you have 11 books over here. So 11 identical things which can be filled in any way you want, and these has to be distributed among these 4 sets, right? So you need 3 lines, right, to do that. So you have a total of 11 plus 3, that's 14 items. So that's 14 factorial divided by 3 are of one type, so 3 factorial, and 11 are of one type, that's 11 factorial, right? So the correct answer is 14 factorial by 3 factorial into 11 factorial, which is the same as 14C3, and that is answer option A. Let's read the next question. How many ways can you arrange the letters of the word mathematics? What's the answer to this question? The correct answer is option A, right? Over here, there are a total of 11 letters, and you can see that M repeats 2 times, A repeats 2 times, and T repeats 2 times. So there are 11 items, out of which 2 are of one type, 2 are of one type, and 2 are of one type. The number of linear arrangements is 11 factorial by 2 factorial into 2 factorial into 2 factorial. That gives you the answer as option A. Let's read the next question. In how many ways can you select 2 numbers from the first 60 numbers such that the product is divisible by 7? Alright, what's the answer to this question? The correct answer is option C, that's 444. Now, how do you do this? You just find all the ways in which you can select 2 numbers and then you subtract the violations. Alright, now in how many ways can you select 2 numbers from the first 60 numbers? You can do that in 60 C2 ways. What about violations? The numbers have to be such that when you take the product, the value that you get has to be divisible by 7, right? Therefore, at least one of the numbers should be a multiple of 7. Then only this will happen, right? Now, violations would be when both the numbers are not multiples of 7. Alright, So how many numbers in the first 60 numbers are there such that they are multiples of 7? There are 8 numbers, or 60 by 7, right? If you take the first 60 numbers and you want to know how many multiples of 7 are there, you just need to do 60 by 7, that's equal to 8, and you get some remainder, right? So there will be 8 numbers in the first 60 numbers which are multiples of 7. Which are these numbers? You'll have 7, you will have 14, you'll have 21, etc. up to 7 into 8. How much is 7 into 8? That's 56, right? So these are the 8 numbers which are there in the first 60 numbers such that they are multiples of 7. Now, if you remove these 8 numbers, you are left with 60 minus 8, that is 52 numbers. Now, if you select 2 numbers from these 52 numbers, then the product will not be divisible by 7, right? Now, you can select 2 numbers from these 52 numbers in 52C2 ways. Therefore, the answer to this question is 60C2 minus 52C2, and you can simplify it as 60 into 59 by 2 minus 52 into 51 by 2, and that will give you the answer as 444, which is option C. Let's read the next question. Matthew draws 4 parallel lines. Next, he draws 3 parallel lines that intersect the previous set of 4 lines. For example, these could be the 4 initial lines, and then he draws these 3 lines which are intersecting the initial set of 4 lines. Alright. Now, the question says, how many parallelograms can he form? Alright. Now, over here, we need to remember that a parallelogram is a shape such that opposite sides are parallel, right? These 2 sides are parallel and these 2 sides are parallel to each other. So this type of a shape is called a parallelogram. You can see more of this under the geometry section. Now, all you need to do to form parallelograms is you need to select 2 parallel lines, that's these 2, and then you need to select 2 more, that's these 2. So they will form a parallelogram. For example, if you select this line and this line and this one and this one, you'll get a parallelogram like this, right? This is 1 point, this is 1 point, this is 1 point, and this is 1 point. So this would be one parallelogram. Similarly, you can form a lot of parallelograms. So the correct answer is option C, right? 4C2 ways is the number of ways in which you can select 2 parallel lines from these 4 lines, and 3C2 is the number of ways in which you can select 2 parallel lines from these 3 parallel lines. So the number of parallelograms that can be formed is 4C2 into 3C2, that's 6 into 3, which gives you the answer as 18. Let's read the next question. How many 3-digit numbers can be formed using the digits 4, 5, 6, 7, 8 such that no digit is repeated? Alright, what's the answer? The correct answer is option A, that is 60, right? You're given 5 digits. So this is a 3-digit number. This place can be filled in 5 ways. This place can be filled in 4 ways because 1 digit has been used for filling this place. Now this place can be filled in 3 ways. So the number of digits that can be formed is 5 into 4 into 3, which is equal to 60. That gives you option A as the answer. Let's read the next question. In a meeting, every person shook hands with every other person once. There were a total of 36 handshakes. 2 people left early and 3 more people joined. At the end of the meeting, everyone shook hands again. Find the number of handshakes at the end of the meeting. So you just need to find the number of people at the end of the meeting, right? So what's the correct answer? The correct answer is option B, that is 45, right? Because NC2 is 36, right? So you'll get that N is equal to 9, right? Why? Because 9 into 8 by 2, that's 9 into 4, which gives you 36. So you can just try few numbers, you can easily find which value suits N. Over here NC2 is 36, so N is equal to 9. Now 2 left and 3 joined, so there will be 10 people at the end of the meeting, and to find the number of handshakes when everybody shakes hand exactly once with everybody else, you just need to do 10C2. That's the number of ways in which you can select 2 people out of 10 people, and 10C2 is nothing but 10 into 9 by 2, right? And that is equal to 45. So your answer is option B, that's 45.